There we go. Okay. So we are talking two different ways that we can show that triangles are congruent to each other. Besides just showing what we did yesterday with every single pair of sides and every single pair of angles being congruent, it was figured out a long time ago that you can show that three things are congruent, three pairs of things congruent, depending on what those pairs are. And that's sufficient to show that two triangles are congruent to one another. So we want to be able to identify congruent triangles using these two different ways that we're going to talk about today. One is called SAS, and the other is called SSS. And we will talk about what those letters stand for in a moment. So whatever you're taking notes with, go ahead and grab that, and we'll go ahead and get started here. So it's kind of 5.3, 5.5 together, but we will spend more than one day going over the both of these. It is SSS and SAS congruence. SSS and SAS congruence. Okay. No, pen. All right. So what SSS and SAS stand for, when we talk about this kind of, actually first, let's back up a moment. In order to show things are congruent, yesterday we had that CPCTC, that corresponding parts of congruent triangles are congruent, or if you just want to call it corresponding parts. You can. So that was where if we wanted to show that two triangles were congruent, or this was, I guess, something that happens because triangles are congruent. But if we had like A, B, C, and D, E, F, and we wanted to show triangle ABC is congruent to triangle DEF, typically, if you wanted to show triangles are congruent, you would have to show that angle A is congruent to angle D, that angle B is congruent to angle E, that angle C is congruent to angle F. So we would have to show all of these things. And then we'd also have to show that AB is congruent to DE. We would have to show that BC is congruent to EF. And we would have to show that AC is congruent to DF. So if I wanted to show that two triangles are congruent, I would have to show all 6 of these things typically. But we have some theorems that kind of help us cut down on the amount of things that we have to show in order to determine that two triangles are congruent to one another. So that's what we're doing today. So first we're going to talk about SSS. SSS stands for side, side, side. Or postulate. Okay. So it stands for side, side, side congruence postulate, or we'll just call it SSS. And in SSS, all you have to show for determining that things are congruent is that you have 3 pairs of congruent sides. to determine congruence. All right, so this cuts down a lot on the things that you have to show. So I could show, instead of showing everything being congruent, I could just do the sides. Or if I have two triangles like this, okay. So if I'm shown two triangles like this, and we know that they each have a matching side over here, I can determine that, yes, these triangles are congruent because of side, 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 because of SSS. And so I might be asked, are these triangles congruent? And so we would say, yes, they are congruent. By SSS. That might be our question. Are they congruent? We'd say, yes, they are congruent because of SSS, because we have one here, 2 and 2, 3 and 3 that match up. Now, what we might also have to do is create a congruence statement here that shows which things go together. So we might be told to then write a congruent statement for them. So we might be given something like that and asked to fill in the blanks with two triangles that are congruent to one another, making sure that we follow through on the letter order. Okay, so you can start over here with any letter order you like. On your first triangle, you can go through any letter. I can call it PST if I want to. I can call it TPS or TSP, whatever I would like to. So I'm going to start with PST over here. But since I put PST, I need to put some letters that go with PST over here. And it's a little bit harder to do without the angles labeled in the picture. So here's what you do. First off, we have to figure out what goes with P. P is between the one with one line in the side and 3. So P is between 1 and 3. So then we have to find the one over here that's between 1 and 3. Which one over on this triangle is between 1 and 3? What do we think? Which letter goes between 1 and 3? Okay, so here's 1, here's 3, and here's 2. So this one's between 1 and 2, this one is between 2 and 3, and this one is between 1 and 3. So between 1 and 3 is L. Nice job, Owen. So L would come first. Then, since I went from P to S, S is between 1 and 2. Which one over here is between 1 and 2? Oh, exactly, Lauren. And then by process of elimination, M must come last. Okay, so that's how with SSS we would write a congruence statement. Okay, so that's one type of problem that you guys will see today. Any questions at this point looking at that one? Any letters we're not sure where they came from, or things we're not quite sure how they happened? Okay. If at any point you do have a question, either unmute yourself and say so, or type it in the chat, and I will read it out of the chat. Okay. We're going to do another one that's similar to this. And it's going to look a little bit more like ones that you might see on your homework today. And I need another piece of paper. All right, in this one, I'm going to be showing you 3 different triangles. 2 of them are congruent to each other, and one of them is kind of the odd one out. What's a letter I haven't used yet? N. Okay, so we want to be able to pick out which 2 are congruent to each other. And we want to be able to write congruent statement. Okay. So first of all, we need to pick out which ones are congruent to each other. So we have on this one, we have a 1 and a 3 and a 3. On this one, we have a 1, a 2, and a 3. And on this one, we have a 1, a 3, and a 3. So that would tell me that these 2 are congruent to each other, the ones with the 1, 3, and 3 going on. And when you have 2 sides that are the same, you'll end up with kind of more options for your congruent statements. So when we go to write our congruent statement, if I start with this one here and I go PSL, pumpkin spice latte. So if I go PSL for that one, then we need to figure out over here which one goes with P, which one goes with S, and which one goes with L. So P is between 1 and 3. Over here, which one's between 1 and 3?
Wait, Miss Lindell.
Yeah.
Why would we start with the letter that's in between 1 and 3 instead of 1 and 2?
This one doesn't have 2, but it doesn't really matter which one you start with. If you're asked to just write a congruent statement, you can start with any letter order you want to for this one. So I could have gone SLP or LSP or LPS or whatever letter order I would like to for my first triangle. The second one, though, has to match with your first one.
Oh, okay.
Yeah, good question. And yes, it's N and M are both between 1 and 3. M is between 1 and 3, and N is between 1 and 3. Okay. So starting off with between 1 and 3. So if we're leaving it up to, I guess if we were complicating things, we would talk about, okay, well, 1 is on the left of, or on the left-hand side of M, and 3 is on the right-hand side of M. Whereas with P, it's also 1 is on the left and 3 is on the right. But really, it doesn't matter because you could flip the triangle over and things like that, and it wouldn't actually make a difference. So really, you can pick either one of these. I'm going to pick M. Since they're both between 1 and 3, you can pick either one. Then we go from P to S. This is where you have to be careful, though, when you go from P to S, because S is between 3 and 3. So you do have to make sure that you pick the one over here that's between 3 and 3. So in this case, O is between 3 and 3. And then the last letter is N by default. So PSL would go with MON. Okay. So again, you can start with whichever letter order you like, but you have to end up with a letter order that goes with it. Okay. Any questions on this one? Okay. I'm going to give you guys one to try. See if we can get it. Okay. So we want to know which two are congruent and write a congruent statement for them. And keep in mind there are multiple correct answers here as to your congruent statements, depending on what you pick for your first triangle. So take a couple minutes when you think you have it. Let's see. Type caramel apple in the chat when you think you've got it. All right, you're on the right track if you chose these ones. And then as you finish, what congruent statement did you pick? How did you write your answer? If you started with this triangle, you could have, let's see, if I put AMP, or you could put PMA or PAM, or however you want to start it is fine. Since A is between 2 and 4, S is also between 2 and 4, so S would come first on mine. Then M is between 2 and 3, and T is between 2 and 3, so T would come second on mine, and then Q would come third. So you could have this for your congruent statement. You could have, there's a lot of different, whoa, tossing things around. There's a lot of different options, as I wave my hands about, that you could pick for your congruent triangle statement. If you did PMA, for example, then it would be QTS. If you did APM, then it would be SQT. So there's a lot of different options here. If you had, so just because I didn't list your option doesn't mean it's not right. If you want to check it with me, feel free, type in the chat what you had, and I can say yay or nay. But that's SSS congruence there. That's everything we need to know about SSS. So the next one that we need to do is SAS. And SAS congruence is going to have some similar things to SSS congruence. And it's also, I think, slightly easier to identify than SSS, or easier to write congruent statements for. Not necessarily easier to identify, but anyway, SAS stands for side, angle, side congruence postulate. Side, angle, side congruence postulate. So, as you might have figured out by now, S stands for side and A stands for angle in any of our congruence postulates. And there will be a total of 4 for us with this chapter. So there will be 4 congruence postulates that we deal with, and they all use the letters S and A. And we are just hitting 2 of them today. So side, angle, side means you have to have show one pair of congruent angles and 2 pairs of sides but order matters here. It has to be side, angle, side. So it has to be the angle with the 2 sides that are on either side of it. So what we mean by that is if I know that this angle and this side are congruent to another triangles, then this works. This is what we mean by side, angle, side. If I had something like this, though, just because I know 2 sides doesn't necessarily work out, because the 2 sides that I know are not on opposite sides of my angle here. So there is no angle, side, side. There's only side, angle, side here. So this would be a no. This would be yes. So this is side, angle, side. This is not. Okay. So for example, we're going to see similar problems on our homework assignment to the ones that we saw for side, side, side. We'll see something like we'll see something like that. And let's see, some information that might be included. We might see something like that, and we'll be asked to write a congruence statement for the two that are congruent. So we will have to go through and decide which two go together. Well, this one has a 1 and a 2, and it has an angle with 1 arc in the corner. This one has a 3 and a 2 and an angle with 1 arc in the corner. This one has a 2 and a 1 with an angle with 1 arc in the corner. So that would tell me that these two are congruent to each other. Okay, so then when it comes to writing the congruence statement, the easiest way that I think to do it is to start with the angle that you have a marking on, and then kind of go from there. So I would either call this one HSP or HPS. Either one is fine. I'm going to go with HPS. Then over here, I already know that I must be starting with L because H and L go together. So I would start with L. And then on here, I went from H to P. That goes along the side that has the 2. So from H to P is the 2 side. So then from L, I would go along the 2 side to A. And then lastly would be M. So we'd have HPS and LAM. Again, there's other ways that you could do it if you wanted to. But that's the way that I would personally do it. Start with the angle that you know, because it's really easy to match up angles. It's a little bit harder to match angles and sides and things like that, like we did with SSS. Okay. Let me have you guys try one. Okay. So pick two that you think are congruent, and then write a congruent statement that goes with them. When you think you're done, type Velociraptor in the chat. And if you chose those top two, you're on the right track. All right, as we finish, if you did ABC or ACB for your first triangle, that's probably what I would do first. Or you could do HIG or HGI first. Either one is fine. So starting with A means we start with H over here, because A and H go together. And then if I went from A to B, that means I went along the side with the 2. So from H to I, and then lastly G. Or if you did ACB, that means you went along 1 first to C. So from H, you would go to G, and then to I. So either of these ways of writing it is fine. There's lots of other ways that you could write it as well. So if you wrote it a different way, it's not necessarily wrong. If you want to check it, feel free to type it in the chat and ask. Otherwise, at this point, I am going to post the homework, and then if you would like to go over more examples with me, you can stick around and go over more examples with me. So going to the homework today, we have one IXL section, and that is all. So it's going to be a shorter homework night. So it should now be posted. Okay, one IXL section to 80, and it's called SSS and Sas theorems. It's the IXL K1. So it will show you pretty much the exact kind of things we were going over on the examples. It'll say, which 2 triangles are congruent? Complete the congruence statement. So this one has 1, 3, and 4. This one has 1, 3, and 4. This one has 1, 2, and 4. So these 2 would be the ones that we look at as being congruent. For your first triangle, you can type whatever one you want. I'm going to go PQR. And then I started at P, which is between 3 and 4. And over here, W is between 3 and 4. So W would be my first one. Then we went to Q, which is between 1 and 3. And over here, Y is between 1 and 3. So we go with Y next. And then lastly, X. Okay, and then we have SAS theorem, same idea. So we will have an exit ticket later. You are free to go and start working on this. If you have questions, stick around, or if you want to see more examples, stick around.